diagram will be totally different little bit. So what is the rheostat? It will be, structure will be like this. Later on, I'll send one diagram. I'll upload diagram later on. Okay, this will be the basic structure. So it will be, this will be a stand, and here what will happen, turns will be there. So I'll having a connections where this will come. So I'll connect a wire, one wire here, other wire to this one. This will be used for making connection. So now this is the X. There's a handle which you can movable. So this is the connections which you are going to make it, say A and B. So definitely what happen, this part of resistance, what happen will get added up to A and B. As I shift it, again this will increase. So each turn will add some resistance continuously. A coil, I'll wound it. So definitely this much of resistance will come into the picture. So as you move it here, the total resistance of rheostat will come. So if you move this like this one, you can say handle, if you move this handle towards left, no, the resistance offered RAB will decrease. So RAB depends upon X, the length of X button. So here the connections will be made. What is this? These are the stands and these are the turns. Wire will be owned. This is one basic idea. So it's a very easy equipment, means very easily you can vary the resistance here. It's asking now find the minimum and maximum current through the ammeter. What is the maximum permitted resistance here? 30 ohm. So you'll get rheostats of 100 ohm, 30 ohm, 50 ohm, 10 ohm, 1000 ohm, 10,000 ohm. When the movable, okay, these are the some points are there, P1 and P2. When this handle is at P2, it will offer the total resistance. When the handle is at P1, it's as good as no resistance, no resistance will be 0. Able to get this? So this is what that arrow they show it. It's a movable. No? I'll bring like this. So if arrow is here, no resistance will come. So like this, as I move this arrow, so what will happen to resistance that will come in series with ammeter will keep on increasing. When this arrow is here, exactly at this point, not visible, some are telling. Yeah. Okay, now able to see clearly. So what is the resistance will be? Will be 0 ohm by the rheostat. Only 6 ohm, 12 ohm in parallel is what's seen by the cell. So as I move this arrow, suppose exactly somewhere here 5 ohm, 10 ohm, exactly at the midpoint, 15 ohm will get added up to the circuit, to the ammeter in series. When the arrow is here, when the handle is here, all the 30 ohm will get added up. That's only the basic idea of the rheostat. Fine. So what is that arrow I'm moving is what? That handle. Let's have like this here. Okay, what is the minimum? When the arrow is at the left point, that will be minimum. No? So instead of drawing circuit, let me put it here. When the resistance is, when the arrow is at P1, okay, I'll write this as J. And J is at P1. When the handle is at P1, then what is the effective resistance? 6 ohm parallel to 12 ohm, and we'll get a current. Shall we go for maximum? That is 4 by 6 into 12 by 6 plus 12. 4 into 18 by 6 into 12. You'll get I max. Then when J is at P2, then I minimum will be 4 by, these two will be as usual parallel, and the rheostat resistance will get added up, 30. That will be minimum current. So by varying this position, you can control the current through this branch. So that's the main purpose of the rheostat. Okay, so will rheostat will dissipate energy? Yes, because any resistor should dissipate energy, no, here. So energy will be dissipated here. So what about this here? No flow of current here. Current will flow in this one. So I'll just give the direction of current. Here it will branch out I1, I2. Here the current